Hi guys, how are you doing? Welcome back to Physical Chemistry lecture series. In previous lectures, we had discussed about chemical kinetics. In today's lecture, we are going to discuss about spectroscopy. Okay, spectroscopy. So with the help of this spectroscopy, we can able to determine the structure of compounds or simply organic compounds. Okay, so first we should know about the spectroscopy. Spectroscopy is study of interaction of electromagnetic radiation with the matter. Okay, spectroscopy is study of interaction of electromagnetic radiation with matter. So therefore, the branch of physical chemistry which deals with interaction of electromagnetic radiation with the matter is known as spectroscopy. Okay, so the branch of physical chemistry which deals with interaction of electromagnetic radiation with the matter is known as spectroscopy. Okay, so it is known as the spectroscopy. So in this case, just we are taking the matter. So assume it is a matter or a molecule or an atom or simply a particle. Okay, so take the particle. Take the particle and irradiate with the light. Okay, so if we irradiate the particle with the light, this particle may absorb certain amount of the light. Okay, it can absorb the light and remaining amount will be transmitted or reflected. Okay, so assume certain amount will be transmitting. Okay, it is transmitting. So this is the electromagnetic radiation. Okay, EMR. Just we are taking the particle and irradiating with the electromagnetic radiation. If you do so, then it can absorb certain amount of the light and the remaining one will be either reflected or transmitted. Okay. So if you see the intensity of this electromagnetic radiation, that means incident light. Okay. So if you observe the intensity of the incident light and intensity of the transmitted light, so there we have the a few changes. Okay, so in the first cases, that means if you see the incident light, its intensity is very high, whereas if you take the transmitted light, so in this case its intensity is less because certain amount of the light can be absorbed by the particle. Okay, so that's why we have the smaller changes. So if we observe these changes, that means if we analyze these changes, then we can able to get the structural information of this particle. Okay, so by analyzing this light, okay, we can able to find out the structural information that we are calling as the spectroscopy. Okay, so anyway, in the present case, our particle is interacting with the electromagnetic radiation. Okay, it is interacting. So once it is interacted, then what happens? The outermost electrons can be goes into the higher states or higher energy levels. Okay, so let me take the Bohr model. So assume, so this is the nucleus. Here we have the fixed state or stationary states. Okay, so molecules or atoms have the stationary states because their energy is fixed one. So we can call them as the stationary states. So here we have the two stationary states. So assume in the first state we have the electron. Okay, so in the first state we have the electron, and if we irradiate this particle with the light, so it will be taking light energy and goes into the excited state. So it can be jumped into the another state. Okay, so now it is on the second state. Okay, so also this is the n is equal to 1 first state, and here is n is equal to 2. Okay, so by absorbing the light energy, this electron can be going into the higher energy level. Okay, so that's what we can say this molecule now as excited. Okay, it has excited. Okay, so now what we are doing, we are analyzing this intensity of light. Okay, we are analyzing the light. Okay, and again here we can get the doubt. So which light we have to analyze? Okay, because now particle has been excited. So after getting excited, it won't sustain there for longer time. That's why it can be again come back to the ground state. So here we have the energy for the excitation as well as the energy for the de-excitation. So that's why we have the two types of the lights here. Okay, so we have the two types of the lights. Okay, so that means here we have the two types of the energies. Okay, one is absorbed energy and second one is emitted energy. So if we observe the absorbed energy, then that can be called as the absorption spectroscopy, because you are taking the absorbed energy and analyzing it. That is absorption spectroscopy. Whereas if you take the emitted energy for the analysis, then it called as the emission spectroscopy. So overall, molecule shows two types of the interactions. Okay, so here molecule is showing the two types of the interactions. One is absorption and second one is the emission. Okay, so let me take this absorption. So just you also, here we have the stationary energy states. Okay, so here we have the ground state and this is the excited state. That means n is equal to 1. Otherwise we should write it as the En. Okay, otherwise Eg. Eg means ground state. Okay, and this is excited state. Okay, excited state. So here n is equal to 1, here it is n is equal to 2. So now here we have the electron. So if you provide the energy, this electron can be goes into the higher energy level. Okay, so it is coming here. Okay, so here it is H nu. Okay, so if we observe this energy, okay, if we analyze this absorbed energy of the particle, then we can get the absorption spectroscopy. Okay, so anyway here particle is taking the energy. Okay, it is taking the energy from the electromagnetic radiation. So that's why it is the absorption. Okay, so absorption means the process in which a particle will take the energy and goes into the excited state. So that is called as the absorption. Okay, so that is the absorption. Whereas in other cases, so let me take the same configuration. So here we have the lower level as well as the higher energy levels. So this is the lower energy level. We can call it as the ground state. Whereas this is the higher energy level. We can call it as the excited state. Excited state. Okay. So here what happens? Now here we have the electron. Okay. So we have the electron in the second energy level. So now it is highly energetic. So won't sustain for longer time. So that's why it can be gives the energy to the surroundings. Okay. It can use the energy and come back to the ground state. Okay, so here it is releasing the energy. Okay, if this energy is taken for the analysis, we can get the spectrum. That spectrum is called as the emission spectrum. Okay, and this process is called as the emission. It is the emission. Emission. It is emission, whereas this is absorption. Absorption. Okay, so anyway molecule is showing the two types of the interactions. Okay, so if we fall the electromagnetic radiation on the particle, it takes a certain amount of energy and goes into the excited state. That process is called as the absorption. Whereas in other cases, so the excited particle can use energy and come back to the original state. So that is called as the emission. Okay, so that's why particle is interacting in two ways. So one is absorption and another one is emission. Okay, so anyway, spectroscopy is a technical procedure by which we can measure the energy differences between the allowed states of a system by determining the frequencies of corresponding light, absorbed light. Okay, by determining the frequencies of corresponding absorbed light. Okay, so it is simply a technical procedure used to determine the which one energy differences between the allowed states of a system. Okay, so allowed states of the system. So anyway, in organic chemistry, the most common and very important job is to determine the structure of the compound. Okay, structure of the compound. So anyway, that we take the compound. So it is unknown compound, unknown compound, unknown compound. So it is unknown compound. We don't know whether it has been synthesized in the lab or isolated from the natural resources. Okay, so anyway, that's why what we have to say, we have the two types of the compounds. One is synthesized in laboratory, synthesized in lab. Another one is obtained from natural source. Okay, obtained from nature. Nature, that means natural resources. So if it is synthesized in the lab, then we can call it as the synthetic compound. It is a synthetic compound. Synthetic compound. Whereas if we isolate the compound from the natural resources, it is called isolated compound or natural product. Okay. Simply if you say it as natural product. Natural product. Okay. So that's why what I was saying, we have to determine structure of the synthetic compound or a natural product. Okay, so we don't know which category it will be false. So generally we have the two types of the categories. One is synthetic compound and another one is the natural product. So in the first instance we don't know where it can be false. So that's why we have to find out this structure. Okay, suppose if it is a synthetic compound, that means if it is a reported compound, then its description can be find out somewhere in the chemical literature. Okay, so if the compound is known compound, okay, if the compound is a reported compound, so then its description can be found somewhere in the literature. Okay, so if it is found somewhere in the literature, we must identify it. Okay, we must identify it. Whereas in contrary, if it is a new compound, okay, if our compound is a new compound, then we have to carry out an elaborative structural elucidation. Okay, we need to carry out an elaborative structural determination. Okay, so if you want to carry out the elaborative structural determination, first we need to isolate the compound. That means we have to purify the compound. Later, we need to find out its physical properties like melting point, boiling point, density, refractive indices, and solubility in different solvents. Okay, so in different solvents. So later, by using this spectroscopic method, we need to find out the structural information of that compound. So in spectroscopy, especially two spectra are used. That means we have the various types of the spectroscopic methods. Among them, we can generally use the NMR, that means nuclear magnetic resonance spectroscopy, and infrared spectroscopy. Okay, and the instruments which were used to determine the structural information are called as the spectrometers. Okay, we can call them as spectrometers. Okay, spectrometers. Spectrometers are spectrophotometers. Okay, spectrophotometers. Spectrophotometers. Okay, so the instruments which were used to determine the structural information of organic compounds or inorganic compounds are called as spectrometers or spectrophotometers. So anyway, spectroscopy is essentially used to determine the structure of compound. Okay, so this is essential technique used to determine the structure of compound. So let me take the advantages. Okay, so we should take the advantages of these spectroscopic methods. So let's go what they are going to see. Okay, advantages. Advantages of spectroscopic methods. So if you take the advantages of the spectroscopic methods, so we have the large number of the advantages. So let me see the first one. So if you take this spectroscopic method, it is extremely sensitive. Okay, our spectroscopic method is extremely sensitive and we require the very less time. Okay, that is the first advantage. Okay, so what we are saying, this spectroscopic method is extremely sensitive and requires less time. Okay, so it is extremely sensitive, extremely sensitive and require less time. It is extremely sensitive and require less time. And second one is, for spectroscopic methods we require less amount of the compound. Okay, so for this analysis we require the less amount of compound, and that compound again can be retrieved and reused for the other test. Okay, so spectroscopic methods require less amount of the compound, which again can be retrieved and reused for the other test. Okay, so that's why here what we can write. So require. Okay, require less amount. Okay, we require the less amount, and it can again be retrieved and reused for other tests. And it is retrieved and reused for other tests. Okay, so this spectroscopy requires the less amount of the compound, which again can be retrieved and reused for the other tests. Whereas if you take the classical methods, so there we don't retrieve the compound. Okay, so we can lose the compound, but in this case we are retrieving it and using for the other purpose. And the third one is, spectroscopic methods provide highly reliable information. Okay, so this spectroscopic method convey the highly reliable information, and that information again can be obtained in the form of permanent record. Okay, so what we are saying, this spectroscopic methods convey the highly reliable information, and that information can be obtained in the form of the permanent record. Okay, so once we can get it, so we don't that means it is constant. Okay, it is permanent record, that's it. Okay, so it can be sustained for the any time, that means so it is not changeable. Okay, so it is permanent. Okay, so that is the third one. So that's why what we are saying, conveys highly reliable information. Highly reliable information. Highly reliable information. And obtained in the form of permanent record. Permanent record. Obtained in the form of permanent record. Okay. And the fourth spectroscopic method most often, it is most often carried out in the continuous process. Okay, so this method is a continuous process. We don't require certain time. Okay, so that means we don't require the break. Okay, so it is a continuous process. You can get information of compounds. Okay, so it is the continuous process. Continuous process. It is a continuous process. We don't require any break to determine the structure of organic compound. Okay. Yes. And one more important point is, so if we want to take these spectroscopic methods, it does not provide directly a structure of the compounds. Just it simply provides the structural information. From that structural information, we can be able to find out the structure. That means, so in order to find out the structure of the compound by using this spectroscopic data, so we must have the skills. That means scientists have the good skills. If we have the good skills, then we can able to find out the structure. Otherwise, if scientist is lack of the skills, then we don't get its structure. It is simply provides the structural information. Okay, so this is about the introduction of the spectroscopy. So I can stop here and we will continue.